Thank you, Todd. Yeah, like Todd said, I'm Ken Moreland from Oak Ridge. I'll be talking a bit about Viskores. Before I begin, I just want to give some acknowledgement first to our funding sources. Viskores is primarily funded by the Rapids SIDAC project. We've also gotten quite a bit of funding over the years through other Office of Science funds, such as the ECP program, as well as their Oscar research program. I'd also like to thank the many, many partners that we've had in labs, universities, and industry over the years, without whom it would be impossible to do the software that we managed to achieve. So just start by what is Viskores. Viskores, in a nutshell, is visualization on accelerators. So since the 2010s, we've seen in HPC the majority, at least on the largest machines, of floating point computation comes from things like GPUs that have an extraordinary amount of parallelism associated with them, and the visualization and data analysis has to move along with that as well. And when people think about visualization, oftentimes they think about rendering, and certainly this is a big part of what we do in a visualization package, but there are many, many more things that we have to do in order to provide proper analysis of data, oftentimes data off of simulations. For example, we do contouring and other feature extractions and definitions, estimate particle densities, perform advection and other flow algorithms, as well as topology algorithms and many, many more, in addition to, of course, rendering. So all of this needs to be done and done efficiently on our HPC systems. And I'd like to talk about why we do Viskores in the first place, because when Viskores was first started, there already existed multiple visualization libraries, including scientific visualization libraries, that were well established. The biggest one, and the one that continues today, is called VTK, which was started back in the 1990s and has become the de facto standard for scientific visualization, including on HPC systems. And the reason is that, as I mentioned, back in the 2010s, we saw a big shift in how we constructed HPC platforms that left a gap in what these products could do. So, of course, as we all know, I'm sure in this room, is that we build HPC systems based off the cluster model, where we take machines that are more or less just workstations and put them together in a rack, connect them with a high-speed interconnect, and then we write MPI programs or other types of distributed parallel programs that run programs independently in each one of these nodes and have them work together on the same problem. Now, we've had multiple different products in production that do this quite well for scientific visualization, including things like ParaView and Visit. But what's changed is in this model, we sort of assume that there is a single core running in each one of these nodes, and this is just not true anymore. So where ParaView and Visit could scale up to tens of thousands of nodes, within each one of these nodes now, we might have tens of thousands of threads. And simply trying to do MPI parallelism across all of that is just not going to work. And so this is where the gap came in, and this is where Viskores sits, is it exploits the parallelism that's available within each of these nodes, and then integrates into this overall parallelism of the distributed memory system to achieve the hybrid parallelism that's necessary for these large-scale systems. Another thing that Viskores has addressed since its inception is the understanding that the different types of architectures that we experience in HPC systems can vary quite dramatically. We still do have CPUs, and we want to take advantage of the parallelism there, but we also see various different vendors with different types of GPUs, and we may see more exotic products in the future as well. And we wanted to be able to create a set of abstractions that allows you to implement a visualization algorithm once, and then once that's implemented, Viskores will automatically port that portably, performantly across all these different types of platforms. We do actually leverage Cocos, particularly for the newer platforms in there, but it is something that we've been doing from the very start. And so we've had a lot of success with this model. We've managed to scale across the entirety of Frontier. In fact, one of our test problems was one of the first programs that was able to scale to the majority of the Frontier supercomputer, and we're able to demonstrate using a simple noise generator of rendering images of this nature in about a third of a second. We've also integrated with multiple other products. Most of this comes at the tail end of the ECP, where you can see on the slide in the upper right, we've done some work with Ascent and the WarpX program, being able to do in situ visualization and other particle detection for them. We've also worked with some folks from Fusion, really accelerating what we're seeing here is what's called a Poincare plot, reducing the amount of time it would take to do these plots from on the order of hours to minutes, which really allows for much deeper analysis of the physics that are there. All right, so with all that background, we get to the question, is that why was Viskores keen on joining the HPSF? And one of the biggest motivating factors was to help Viskores really integrate closer with what we see as the end users, the customers, the people that would end up needing the functionality that we provide from Viskores. Now, from the very start, Viskores has been designed to be integrated into existing software. As I mentioned earlier, even when we started Viskores, there was already existing many different production products that were being used to satisfy a lot of DOE users' scientific problems. And we had no intention of trying to completely replicate all of that work and replace it. And so instead, Viskores was designed to be integrated into that work and work within them. But what that means is that we're now kind of 1 degree separated from the end user peoples that actually have the interesting problems that you want to address on the HPC systems. And so we're hoping that the HPSF can help us better interface with these folks and to get better communication between them. What we've found since joining the HPSF is we also get several other side benefits that have been quite helpful, particularly in supporting the software itself, especially as your funding streams go up and down. One of the big things that we've been able to take advantage of since we started is a continuous integration testing support. So there is a CI work group within HPSF that we've been active in, and it allows us to take advantage of some of the CI testing support at the University of Oregon that we can now use as part of our contributions to Viskores to ensure our product is correct moving forward. And they also provide other sort of support that you usually don't think of as you're hacking away your code, like web design and hosting, graphic design and logos. Although these aren't going to change your software, is that they really do help with the communication and promotion of your software. And finally, our plans in the HPSF, some of the next steps. Of course, we always want to support the open collaborative effort for usable HPC software. That is very important to us, not only for our software, but for the community at large. I don't think any of us could really survive without that. One of our next steps will be transitioning from an emerging project to an established project. Viskores has been around a while. It's quite stable. We probably could have started as an established. But we were in a bit of a software change during that time, and we thought this would be a good time to sort of flex the emerging and establishing project roles within HPSF to see what would happen as we move from one classification to the next. We do have some interest in the work group benchmark, in the benchmark work group that I believe we'll probably be talking about later on in this week. Certainly one of the things that we worry about in our code development is regression of performance, and that's something that's quite difficult to track from day-to-day additions to the code. And then we do hope to leverage HPSF for user group and hackathon community events. And with that, I'd be happy to answer any questions.
Any questions for Ken? Okay, I guess I have one. Sure. Can you say a little more about how you want to interface with customers through HPSF? Like, what kind of outreach do you envision doing, and what kind of like how can we help? What do you think is the most impactful thing we could do to get you in touch with more users and to get more usage for Viskores?
That's an excellent question, Todd, and I wish I had a really good answer for that.
Okay.
I think it would help if there were more app-centric members, software members of HPSF. I know it's we just had WarpX up here, and I actually look forward to talking with folks from there because we actually already, again, through a level of interaction, do scientific visualization for customers of that product, and I just want to make sure that we are also addressing their needs from our standpoint.
Question from Mike.
You had to change your name from VTKM to Viskores. Can you describe a little bit about that process, the how that's gone for you? I think a lot of teams who are thinking of joining HPSF hear about this issue, about the trademark, and get scared by it even before they know what it is. So it'd be interesting to hear your thoughts.
Yeah, that's a good point. So I guess I'll start with the why of the trademark. And in our case, there was a clear trademark issue with the name. Being, as I mentioned, there is a product, VTK, that was not at least ready to join the HPSF. I think there's reasons why it wouldn't be part of the HPSF. But those names are very similar, and that's where the problems come in. So in our case, it really was clear that would have to change, and it was a non-starter. The move over has been fairly smooth. It was probably about a month worth of effort to change out the code base from one system to the next. A lot of scripting to do automatic changes. We actually just did our first release of Viskores proper 1.0.0. I want to say 2 weeks ago. So we're still actually in the process of moving over our customer base as well, and I might be able to tell you later how smoothly that goes. But we have high hopes that this will be smooth going forward. Just to clarify, to make sure that everyone was able to do this, we had a final release of VTKM at the same time we had our initial release of Viskores, and those two software bases were designed to be exactly the same, so that current users could just go to the last version of VTKM, and then it should be a simple transition to go to the first of Viskores, and that would be the easiest way to support them going forward.
What about the community outreach kind of things? Can HPSF help you with that? I mean, this is brand new for your users, right?
Yes, this is brand new for our users. Because we are underneath, I want to say the users that we've been focusing on mostly are the ones that I'm going to actually show in this slide, where we have a very close relationship with. But yeah, the HPSF might help us sort of grab those other users that might not be part of this branch out.
Sorry, I didn't see it.
In one of slide, you have mentioned like this application has worked on 74,000 GPUs, right? So can you just elaborate on that? So the simulation was in distributed nature, or how was it?
I'm sorry, you were asking a question about the distributed nature of Viskores.
This slide, yeah.
This one right here?
Next.
This one?
No, just go back. Go back.
This one?
Yeah, yes.
So the majority of the code within Viskores, I think this is the question you're asking, the majority of the code in Viskores is really dealing with the parallelism on the node. Now that said, that there is some MPI parallelism involved as well. What you're seeing here is mostly sort of a rendering problem. There is a contouring which is embarrassingly parallel, so there's not really a lot of MPI communication there. And then on top of that, there is a rendering layer, and that's where the communication comes in. Basically, it's an MPI reduce, although more clever than that at the end. We do use a third-party library called DIY, which was designed to handle the communication patterns that are common within visualization algorithms running on distributed memory machines. And that's what we're using in systems like that. So basically, we try to leverage DIY as much as possible and really integrate it into the algorithms that do need to do the communication across nodes. Did that answer your question? Okay.
Very quick question. Why the name Viskores? Does it mean anything?
I'm sorry, what?
Why the name Viskores? Or why did you choose that? Does it mean anything, or something easy to search, or?
Not particularly. We needed a name. It's visualization. It runs on a lot of cores. We do use Cocos underneath of it. That's where the K came from. That's it. There's nothing profound.
That's actually more involved than I thought it was. I didn't know that the Cocos was for the K, but the K was for Cocos.
There was some talk about should it be more Cocos, less Cocos, and we settled on, well, we'll put a K, and it
Yeah.
they're already part of HPSF, so we don't have to worry about trademarks, so we're good.
Hint of Cocos. Okay.
Yes, a little pinch of Cocos.
Okay. Well, let's thank Ken again. Thanks for that.